right, let's figure out average velocity. Average velocity, average rate of change, same thing, except now we have some context. All right, so we got a ball that's thrown up in the air. The function for the height of the ball is given by h of t equals negative 16t squared plus 85t plus 6, where t is the time in seconds and h is the height in feet. What was the ball's average velocity between t1 and t2? So it looks like we're looking at a parabola here. Maybe it's opening, right? It's definitely opening down. So we're throwing this ball in the air. And so I want to figure out what the average velocity is between 1 and 2. So maybe these points are like here and here. I don't know. And I want to find the average velocity. Well, that just means, okay, what's the slope of this line? How fast is it changing just in between these 2 points? It'll give us a good estimate about what's happening. How is this changing and at what rate? So to figure out the slope of that line, we just have to use the slope formula. But we write it a little differently, and we're talking about average velocity. So I'm going to write f of t2. Right, this is just the y value. Maybe I'll call this t2 and t1 minus f of t1 divided by t2 minus t1. So if we want to find the average velocity between these 2 points, well, we can just plug it in and use the formula, right? So we need to figure out what f of t2 is. So f of 2 and f of 1. So negative 16 times 2 squared plus 85 times 2 plus 6. Quick mental math. Oh, I'm just kidding. Pretty sure that equals 112. Might be wrong. Pretty sure. Then we got to plug in 1. So same thing. I'm 97% sure that this equals 75. Now we can go back and plug these values in. So f of t2, we got 112, minus f of t1 was 75, divided by t2 is 2, minus 1. So it looks like we end up with 37 over 1. So our final answer is, what is the average velocity? Well, this ball is traveling at a velocity of 37 height in feet, seconds, feet per second. Always give your numbers context.